Oh, nice. Okay, that's way nicer. Hello everyone. Today we will try to make a Tetris using new version of ChatGPT, which is 01 preview. So I'm going to give a prompt and see how long it's going to take for ChatGPT to write the Tetris in C++. Okay, write the Tetris in C++ using SDL2 and open GL. It is up to you to use shaders or immediate mode. What is easier for you?
Write the Tetris game in C++ using SDL2 and OpenGL. It's up to you to use shaders or immediate mode, whichever is easier for you.
Whichever is easier for you. Okay, we will try to go as much as possible, maybe in 1 hour. Let's maybe time limit, maybe not time limit. Let's see how far we will go, and maybe we will just run out of the because it's preview, it's limited, and we'll just run out of stuff. Enter. Okay. That's fun. Let's see. Okay, it's thinking. Okay, there is a cone. So let's read the output.
Sure. Below is a basic implementation of the Tetris game in C++ using SDL2 and OpenGL. This code demonstrates the core mechanics of Tetris, including piece movement, rotation, collision detection, line clearing, and rendering. I've chosen to use immediate mode OpenGL for simplicity. Note, to run this code, you will need to have SDL2 and OpenGL installed on your system. Make sure to link against the SDL2 and OpenGL libraries when compiling.
Okay, this is the cone. I'll read it in a moment.
Explanation of key components. Tetramino representation. Each tetramino is represented using 4-point structures which hold the x and y coordinates of its blocks on the game field. Collision detection. Check collision. This function checks if the current tetramino collides with the walls, the bottom of the field, or other locked blocks. Rotation. Rotate tetramino. Tetramino rotation is implemented around the second block, current tetramino 1, as the pivot point. Line clearing. Check lines. After a tetramino is locked, this function checks for any complete lines, removes them, and shifts the lines above down. Rendering. The game field and the current tetramino are drawn using immediate mode OpenGL. Each block is drawn as a rectangle.
This is interesting. So compiling, running, controls.
Controls. Left arrow. Move tetramino left right arrow. Move tetramino right up arrow. Rotate tetramino. Down arrow. Accelerate tetramino fall nodes. This is a basic implementation and can be extended with additional features like scoring, levels, different colors for each tetramino, and the graphical user interface. Error checking and resource management are minimal for brevity. In a production environment, you should add proper error handling and clean up resources appropriately. Feel free to modify and expand upon this code to enhance the game's functionality and visuals.
Okay, let's look at the code. It's a bit short. Main CPP includes width and height. It's a little bit small, but it's fine. Block size, field view, FPS 60. Field, this is global. That's okay. It's a game, right? Color 1. Function prototypes. Check collision, rotate tetramino, check lines. Initialization, windows. Context, viewport, matrix mode. Okay, so it's setting up GL, setting up random number generator. First tetramino generates tetramino, current tetramino. Okay, so it just populates it from the tetramino X and Y. Okay, that's fine, I guess. Start time, while, pull event, keys. Oh, it's implementing everything. Okay, that's fine, yeah. So there is a delay. Oh, that's interesting. It's doing 60 frames per second. I think it's fine. Check collisions and yeah, anyways, copy con. So main.cpp and let's compile it. Undefined reference SDL. Oh yeah, it should be like this. No. GL viewport. Let's see. It's a glute. I think I need to do this thing. SDL OpenGL. Yeah, I need to do this include. Like this. Glue or for 2D. Yeah, it did include GL, but it did not. What else I need to do? Glue. How I can do this thing? LD flags equals like this. Oh, look at this, it's compiled. And run. What the heck? What? How long it took? I'm streaming for 11 minutes. It's like in about 10 minutes and I was just like yapping a lot. And it just works from the first time. I mean, I guess like that's it. It's like I was expecting to have a lot of iteration with ChatGPT and it's like, oh, you did this wrong, this is not working. It's like I did like a minimum amount of fixing, and basically just because I wanted to use my build system instead of like instructions to build for ChatGPT, and it's already working. I guess we will try to build Tetris with everything. I guess let's do scores. Great. It is working. Can you add the scoring system? Let's push it as far.
Can you add the scoring system?
Push as far as we can. Okay, I'm going to create the repository. Probably I can do status, and it will call init by itself. Yeah, so ignore this. Okay, initial commit. Okay, and now I'm going to see. Let's copy this code first. So I did some changes, but I'll return them back a little bit later.
Certainly, I've updated the Tetris game code to include a scoring system. The score increases based on the number of lines cleared at once, following traditional Tetris scoring rules. I've also integrated SDL-TDF to render the score on the screen. Note, you will need to have SDL2, OpenGL, and SDL-TDF installed on your system. Additionally, you will need a true type font file, e.g., Arial TDF, in your project directory or specify the path to an existing font on your system. Here's the updated code.
Okay, so I need to Arial TTF, but we will find it.
Explanation of key components. Score variable int score 0 keeps track of the player's score throughout the game. Score calculation in check lines. When lines are cleared, the lines cleared variable counts how many lines are removed at once. The score is updated based on the number of lines cleared, following traditional Tetris scoring. 1 line, 40 points, 2 lines, 100 points, 3 lines, 300 points, 4 lines, 1200 points. Render the score, render text function. This function uses SDL-TDF to render text onto an OpenGL texture, which is then drawn on the screen. It takes the message, font, color, and position as parameters. Initializing SDL-TDF. TDF init initializes the SDL-TDF library. TDF open font loads a true type font to use for rendering text. Rendering loop adjustments. After drawing the game field in the current tetramino, the score is rendered on the screen using the render text function. Cleanup. Properly closing the font with TDF close font and quitting SDL-TDF with TDF quit during cleanup. Compiling the code. Make sure to link the SDL to OpenGL and SDL-TDF libraries. Here's how you can compile the code on Linux.
On Windows, font file. Okay. So let's see the differences. So I need to add this here and also remove it like this and remove it like this. Yeah. So string. It's a pretty clean diff. Okay. So it's compiled. So it's picked up SDL-TTF, SDL2. Glue I added manually. Let's run it. Oh, we need font. I forgot about this thing. Arial TTF. Python Amica handwriting to project 01 Tetris, right? And we would do Mika handwriting. Okay. It's just white. Not sure why. Maybe font is not good. Maybe I do not know. So there is no errors. Render text. Let me just say, okay, I see the white rectangular in the top left corner, but no score. Maybe we need to set the color.
I see the white rectangle in the top left corner, but no score. Maybe we need to set the color.
Or blend mode.
You are absolutely correct. The issue is due to blending not being enabled when rendering the text texture. Without blending, the alpha channel, which controls transparency, isn't properly applied, resulting in the white rectangle you see instead of the text. To fix this, we need to enable blending and set the appropriate blend function before rendering the text. Here's the updated render text function with blending enabled.
With blending enabled. Key changes. Positioning the text. Let's make the commit. Initial attempt to add scores in the game.
Initial attempt to add a score in the game.
Oh, let me use AI generated commit messages. Add support for rendering text. Yeah. Render add scores attempt 1.
Add scores attempt 1. Added support for rendering text using SDL-TDF and OpenGL. Updated score calculation in checklines function and added a new variable for the score.
Okay. So now let's copy this thing and it's render text. So render text. Bloop. It compiles. Yeah, it's enable blend and disable blend. Okay. So let's see if I did not miss anything. Enable blending, disable blending, additional adjustment, positioning the text. You might also want to adjust the position there is horizontal to ensure it's fully visible, not overlapping with the game elements. For example, you can position it at 0, 5, 1. I'm not sure, but like let's see first if there is a text. It's a garbled mess. It does change. I applied the blend settings as you suggested, and now it is not a block of the white rectangle, but the text is not readable. Let me try different font maybe. Let's try Droid Sans, for example. Nope. So I don't think it's a problem with the font. It is just bunch of dots and lines. Just bunch of random dots and lines.
I applied the blend settings as you suggested, and now it is not a block of the white rectangle, but the text is not readable. It is just a bunch of random dots and lines.
Just a bunch of random white dots and lines. Set the unpack alignment before uploading the texture data. Place this line before GL text image 2D call. Revisited render text. Let's see. Going to copy it. Render text. Pasted it here. No. Droid Sans. Copy. I keep applying the Clang format. So, okay. It's reformatted, but who cares? Okay, I'll compile. Nope, didn't help. Yeah, I think it's limit of the ChatGPT. We will push through it, right? We will debug with ChatGPT. So this is the code. Unpack alignment. This tells OpenGL that pixel data is tightly packed, no padding between rows. This often necessary than texture width isn't multiplied for. Orthographic projection adjustment. Position conversation. Vertical and pixels. Should render it using pixel coordinates rather than field coordinates. Since we changed the coordinate system. Oh, okay. Let's look. So it suggests to use this instead. I don't think there is a difference. Oh, this thing I deleted by accident. Yeah, just yeah. Upload texture to OpenGL. Not to change here. I think I followed all recommendations of ChatGPT, and it's just black now. Oh yeah, Shall we use our midbrains? So first, let's see if it goes where it's supposed to go. So let's shout score text. It's going to spam, but I just need for a little bit. Yeah, it spam score 0. Okay. So it's trying to do this thing. I think the problem is with the position. So I don't think I did changes with the position. Yeah. So let me see what render text is doing. So it's a texture. So we've got the texture. Surface. Where did they get the surface? Okay, so we made the surface. Render text blended. Message color. Font. So we get the surface. Format. Upload texture to OpenGL. Yeah, I know. Okay, so it suggests to add a surface bean. Okay. So let's do it. It's a good suggestion. Width and height. So let's print. Okay, so width and height. Yeah, 85.
I printed what you suggested.
I'm going to make another commit. Okay, and then let's go to main and render text here. Okay. Run. No, it doesn't do, it didn't do anything. It's stuck in the loop. I'm going to give it to ChatGPT. No improvements. I am going to give you my current code listing, so maybe you would be able to find the issue.
No improvements. I am going to give you my current code listing, so maybe you would be able to find the issue.
Yeah, let's see. So this is the render text function. Let me copy paste it. Yeah, it's added this. Okay, what else? Added ortho, vertex coordinates, texture coordinates, adjustment to the main render loop. Okay, render the score. So I need to put this in here. Okay, recompile. I don't think it's going to help. Nope, it just stuck in the loop. We hit the boundaries of ChatGPT, but it was impressive. It was way better. First of all, it just like took less. It took seconds to write the functional code, which then I was trying to do it in the past with ChatGPT. It took like a 1 hour going back and forth, so it's definitely improvement. But it's still stuck in this problem. Maybe I stated it incorrectly to ChatGPT, but it's cannot It cannot figure out how to fix it. My suspicion is this part is not correct. My suspicion. Something not right in the following code.
My suspicion is that something is not right in the following code.
So let's make another commit. Okay. And give another try to ChatGPT. It just stuck in the loop. It cannot figure out how to fix it, but who knows? Let's see. Oh my god. Score 0. I think it's upside down, but it's okay. Okay, it's making progress. Score for 0. I think it's upside down, but it's a progress. Okay, commit. We see some improvements. But it is upside down and white on cyan.
We see some improvements. There is some text, but it is upside down and white on cyan.
Okay, so it's going to, I hope, yeah, it will give me the full text of the function. Okay, I'm just going to copy paste without reading any explanation. Main, so just paste it here, compile, run. Okay, so it is in right, we can read the score. It's beautiful. 40. 80. 120. It's beautiful. This fixed the upside downness. Sets visual mask if unnecessary. Okay, I don't think it did change the color. Okay, I'm going to read it. Nah.
It's great to hear that there's progress. The fact that you are now seeing some text indicates we are on the right track. The issues with the text being upside down and having incorrect colors are common when dealing with texture mapping and pixel formats in OpenGL. Let's address each issue step by step. 1. Upside down text issue cause. Coordinate system differences. OpenGL's texture coordinate system has the origin 0, 0 at the bottom left corner, whereas SDL surfaces start with the origin at the top left corner. Result. When you map the SDL surface directly onto an OpenGL texture without adjusting for this difference, the texture appears upside down. Solution. Flip the texture vertically. We can adjust the texture coordinates when rendering to flip the texture so that it displays correctly. Updated GL text coord to F calls. Modify the texture coordinates in your render text function to flip the texture vertically.
Modify the texture upload to specify the correct format. Upload the texture data. So I need to update this thing. Aha. Alright, let's see. Swizzle. Let's change the format so it doesn't result the colors. You can use the texture swizzling map. So update it to function. If the text is still incorrect, ensure you specify the correct color, then rendering text. Text color, white color. Text color. Render text. Yeah, text color, it's correct. Okay, I'm going to upload the div. Here is my div. The text now is upside right. but color issue is still not fixed. Now it is white on yellow.
The text is now upside right, but color issues are still not fixed. Now it is white on yellow.
So I bet it should be a RGB, something like this. Okay, let's make the commit. What? Oh, second line is not empty. Okay. So let's see what ChatGPT says to us.
Understanding the issue cause. Color channel mismatch. Even though we've converted the surface to SDL pixel format by 8888, the way the pixel data is stored in memory might not match how OpenGL expects it. This can result in incorrect color rendering. Pixel format and byte order. The pixel format specifies the order of color channels in a pixel. The confusion often arises because of differences in byte ordering, NDNS, and how SDL and OpenGL interpret the pixel data. Solution option 1. Change the format in GL text image 2D to GLRGBA. Let's change the GL text image 2D call to use GLRGBA instead of GLBRA.
Swap in red and blue. Swizzle mask. So let's try this. Option 1. Upload the texture data. So we try this. Yeah. Did not help. It's you know, I think it's this one. A B G R. I think we need to do it with something like this. B G R. Yeah, I guess we need to go with Swizzle. RGB, Swizzle mask. Swizzle mask. Let's try Swizzle. Nope. Swizzle. And let's see. Blue, green, red. So I bet alpha is the should be. Oh, look at this. Beautiful. Okay, so let's say option 2 helped. Now I can see white on the black text.
Now I can see white on the black text.
Let's add levels, maybe.
Let's add levels, maybe.
Let's commit this thing. Oh, I did not, yeah,
Thought for 9 seconds. I'm glad to hear that the text is now rendering correctly and that you are seeing progress with your game. Adding levels to the Tetris game certainly. Let's enhance your Tetris game by adding a leveling system. In traditional Tetris games, the level increases as the player clears more lines and the speed of the falling tetrominoes increases with each level. This adds difficulty and keeps the game challenging. Implementing levels 1. Define level variables. Level counter. We'll introduce a level variable to keep track of the current level. Lines cleared counter. We'll keep track of the total number of lines cleared to determine when to increase the level. Speed adjustment. As the level increases, we'll decrease the delay between tetromino movements to make them fall faster. Adjust game speed based on level. We'll modify the delay variable based on the current level. As the level increases, the delay decreases, making the tetrominoes fall faster. 3. Level up logic. Set a threshold for the number of lines that need to be cleared to advance to the next level. For example, every 10 lines cleared, the level increases by 1. 4. Update score calculation. Optionally, you can adjust the score calculation to factor in the current level. For instance, multiply the points awarded for clearing lines by the current level. Updated code below is the updated code with the leveling system implemented. I'll highlight and explain the key changes.
check lines, explanation of key changes, final, add this include at the top, check lines. Render in the score and level. Okay, global variables, modify checkline function. Okay. Where is it? Just before rendering. Is it here? Oh well. Inside your main loop, before rendering, adjust the delay based on rendering the score and level. Rendering score and level. Check lines. I guess this is it. Okay. Level 1. $80. I'm pretty sure I hit already 10 lines. It did not increase the level. Oh no, okay. Oh, it's faster now. 1. I don't know how many lines to, let's say 2. Let's do Tetris. Yeah. 3, 4. Oh, level 3 already. Okay. So leveling is working. Levels are working. Add more features. What do you think we should add to the game?
Okay, levels are working. Add more features. What do you think we should add to the game?
Different colors for tetraminos. Yeah, let's do different colors. Okay, first let's make the commit. Yeah.
Refactor game logic to include level tracking and adjusted delay. Added includes and variables to track level and total lines cleared. Updated game logic to adjust delay based on level and render level text. Modified check lines function to update level and score accordingly.
Add those global variables. Color, tetramino colors. Define colors for tetraminos. This is not needed anymore. Modify the game field to store tetramino types. Field. It's a still integer. Update tetramino generation. Store tetramino type index. Current tetramino type. At the top, declare variable to store the current tetramino type. The main function when generating a current tetramino type. Oh my god. In the main function, then generating a new tetramino, current tetramino type n. Okay. And then update the code for drawing the field. Draw field. Okay. Update the code for drawing the current tetramino. Draw current tetramino. Okay. Lock the tetramino. What is this? Lock the tetramino. Lock the tetramino. Update the initial tetramino generation. N equals. Okay. Update tetramino generation after locking. Generate new tetramino. Okay. Remove unused variable. Let's compile. Use undeclared identifier and. Okay, let's try it. Yellow. Oh, look at this. Colors. Nice. Cool. So we add colors. Let's see. Implement colors.
Implement colors for tetraminos using a color struct. Implement a color struct to hold the red, green, and blue values for each tetramino color. Use this struct to store the colors for each tetramino type in an array. Update the code to use this array when drawing the tetramino in the field.
Okay. We have colors.
Which feature next? Each of these features adds significant value to the game. If you'd like to proceed with one of them, I recommend adding the next tetramino preview as it's relatively straightforward and greatly enhances gameplay by allowing players to plan ahead. Would you like me to guide you through implementing the next tetramino preview feature or any other feature that interests you?
Yes. Okay, hopefully I'm back. I need to turn on my fan. I thought my laptop would survive, but it's overheated. So I need to. So it's going to be a little bit noise in background because of the fan. So we are adding the next tetramino preview, right? We'll go declare variable to store the next tetramino shape and type. I guess we will implement this feature and probably stop. Generate next tetramino in advance. Generate first tetramino, generate next tetramino. First tetramino, generate next tetramino. After locking the current tetramino, replace the current tetramino with the next tetramino. Generate a new tetramino. A new next tetramino. Lock. Okay. Like this. Update gently adjust the viewport and projection to include the preview area. Screen with screen height. Glue orpha. Initialize OpenGL. Auto identity. Extend with. Okay, so. Okay. Quiz. Adjust the. Okay. Screen width. Like this. Render the next tetramino. Draw the next tetramino in the preview area. In the rendering section. I guess here. Okay. Adjust the position when the rendering score and level. Okay. Okay. Guess I need to do it like this. Render score. Render level. Yeah, I did update screen width, right? Oh, I did set it twice. 6 block size. It's repeating itself. I guess it's bugged. Block size. Oh, wait a second. I deleted the height. Okay. Let's see. Oh my goodness. Okay, I think I'm going to stop stream just because we've got a lot of features in using ChatGPT. That's crazy. Like, how many people can implement Tetris by themselves? Okay, I do not know. Maybe I should continue? Should I continue? Or should I stop?
Adjust window import for preview area. Adjusted window width import to accommodate the preview area of the next Tetramino.
Keep coding. Feel free to continue. Can we update the background of the preview area so we could see the border between the play area and preview?
Can we update the background of the preview area so we can see the border between the play area and the preview area?
Can draw a rectangle covering the entire preview area. This provides a darker shade to distinguish from the play. Dark gray, disable texture blending, draw the rectangle. Okay. Main. Adding the borderline. Background rectangle. Draw narrow rectangle. Okay, let's do this whole thing. Okay. Okay. So let's see if we will get the border. Oh, nice. Okay. That's way nicer. Okay. I guess we're done.
Fixed game field rendering for level dependent delay and added preview area rendering. Added rendering for the game field preview area, including a dark gray background, a white border, and disabling of textures and blending. Also updated the level dependent delay calculation.
It's crazy, but I'm streaming for 1.5 hours, and probably I should stop. I do not know. It feels like it can keep going and we can just make the full game. Yeah, it was struggling with textures. It needed to get some hint from me to understand what is going on. But I think of everything else it did by itself. That's crazy. We are living in the future. I think we're done. Thank you for watching, and hopefully see you next time. Bye.